Alright, now we're on the fifth question in Jim Coroneos' list of 100 integrals. And today we've been given an integral which I've named I for the same reasons I've said in the previous video. And I've made I equal to the integral of sine of x multiplied by secant cube of x dx, or sec cubed of x integrated with respect to x. Okay. Don't get tripped out on the sec cube of x. It might seem like, oh, what kind of substitution we can make? Can we make using Pythagorean identities like sine squared plus cos squared equals 1? Can we use that in this case? And I don't think there's really a need to. You just have to remember that in general, the secant of any function, so secant of x, is it really a reciprocal function, because sec x is equivalent to 1 on cosine of x, right? That's just something that it's not. Don't overcomplicate it. I think this is really the key to solving this integral, by knowing this, okay? And you guys should already know that anyway. And what we're gonna do is we're actually gonna do that to the integrand right now, right? And of course, sec cube of x, right, is pretty much the same as 1 on cosine cube of x. That's what it really is. And let's change that. So I equals to the integral of sine x, sine of x, on cosine cube of x, integrated with respect to x. And like the previous video, this means that we really have to do u-substitution again, because there's no really other way to tackle this question. I'm going to box this as well. And so what we're going to do is we're going to do this on the side here. We're going to let u be whatever the trigonometric function is that has the highest degree, and that is going to be cosine of x, because it has a degree of 3. So we're going to let u be cosine of x. And so therefore, when we take the derivative of u with respect to x, man, that's a bad divider. I don't know what happened there. It's going to be derivative of u with respect to x, and that will be equal to negative sine of x. Right? Once again, derivative rule that you must know. And treating the differential dx as a number, we're going to multiply dx on both sides. And that leads us to du being equal to negative sine of x multiplied by dx. And we see here, just like in the previous question, right? In the previous question, we had sine of x times d of x in the integrand. And it's going to be the same thing here. It's here. This is on the numerator. This is the entire numerator in the integrand. And we have the same thing here. Right? But the only difference is that there's this minus sign in the beginning. Right? And so what we're going to do is we're going to multiply minus 1 to both sides. Right? And that's going to give us negative du is equal to the sine of x multiplied by the differential dx. And here we can see that we can replace sine of x times dx with negative du in the integrand. And of course we can replace cosine of x with u. And so we're going to get the integral of sine x times d of x, which is going to be negative du, and that's on top of cosine cube of x, and we let u be cosine x, and so that means this will become u cubed. The negative in front of du is negative 1, and negative 1 is a constant, so we can take that out in the front, and that's going to be equal to negative times the integral of du on u cubed. Right? And now we know from our indices laws, right? I'm gonna write on the side again. I might box this as well, so it doesn't get confusing. Right? We know that when we have 1 on something, so in this case 1 on u cubed, that's equivalent to u to the power of minus 3, based on index laws, and we can convert this integral into negative 1 times the integral of u to the power of minus 3 integrated with respect to u. And likewise, this is a simple integration. This will be minus 1 multiplied by u, and we're going to raise that to the power, raise the power to we're going to add 1 to the power, sorry, and that will be u to the power of negative 2. And then we're going to divide this by the new power, which is going to be negative 2. And of course, we're going to add the constant of integration. And we have a double negative, so we have a negative here and negative here, and that's going to become a positive. Right? And so we're going to get u to the negative 2 onto plus c. Right? And of course, when we have u to the power of a negative index or negative exponent, we can change that to back into the normal fraction form with a positive index. So u to the power of negative 2 is the same as 1 on u squared, right? And that's being divided by 2, and then plus c. And this is really the same because we're dividing a fraction by a number. We can carry the denominator into the denominator of the fraction on the numerator. So what I mean by that? That becomes 1 on 2 times u squared plus c. And of course, with any u substitution, just like I said in the previous question, we have to replace u with what we originally intended it to be. And we originally wanted u to be cosine of x, so we're going to replace u with cosine of x. So this is going to become 1 on 2 times cosine squared of x plus c. And there we go. So we finally integrated, and that's the end of the question.